right, this is a quick rundown for your lesson for 3A-1. 3A-1 is about point slope form, and we're going to get to that in just a second. First of all, let's back up a second, and these are linear function notes. This is what we do. Linear functions are lines. That's why it has the word line inside of it, and that's pretty much what we've been dealing with for a long time now. We were just using this thing called slope-intercept form, which was y equals mx plus b. The m was the slope, the b was the y-intercept. We already know how to do that one, so let's move on to the next form of a line, which is point slope form. Point slope form looks kind of long, but it's not too difficult. It says y minus y1 equals m times x minus x1. So the m is very familiar. It still means slope. And this y and this x are what is important. This is a coordinate. Whatever coordinate they give you or you need, it's going to go right here. The x1 is the x value for the coordinate. The y1 is the y value for the coordinate. Remember, this creates a coordinate, a place that I can graph on my graph. So kind of just, it doesn't give you the y-intercept anymore specifically, it just gives you a random coordinate. That is why it's called point slope form, because it literally has a point and the slope. Standard form, which we will get to on the next lesson, it looks like this: ax plus by equals c, which is where it's going to take a little bit of calculations, but the standard form will tell you the x-intercept, the y-intercept, and the slope. For the x-intercept, you take the number in the c spot divided by the number in the a spot. For the y-intercept, you take the number in the c spot divided by the number in the b spot. And then for the slope, you take a negative version of whatever is in the a spot and divide it by whatever is in the b spot. All right, let's look closely, or more closely, at point slope form. So first of all, let's practice writing the formula. It is y minus y1 equals m times x minus x1. These parentheses are important. They kind of keep these numbers closed off, and they're multiplying towards the slope, so keep those in parentheses. I'm going to practice this side of these for putting them into point slope form. You're going to practice these on your own, and I'm going to check your answers in a little while. Okay, so first we are given here a point and a slope. I can tell this is a point because it's written in a coordinate style. So I'm going to call this my x1 and my y1, and of course m is -4, which is the slope. So what I'm going to do is I'm going to go into my formula, and I'm going to trade out these values with the values that they just gave me. So I have y minus whatever y1 was, which was 7. So y minus 7 equals the m, which is -4, times x minus x1. Let's go find x1. It's 2. All right, cool. Let's move on. So I have another coordinate and my slope. I can use this coordinate right here to put the numbers in the right place in my formula. So my first thing in my formula says y minus, then it says y1, which is -5. Uh-oh. Normally when I do minus negative, I go ahead and just change that to a plus. So anytime you notice that this is changed to a plus, it's because that number was inserted to the formula as a negative number. So it was y minus -5. The slope is 1/2 times x minus x1, which was 4. All right, so this time these minuses are part of the formula. It doesn't actually mean that these numbers are negative like we're kind of used to. It is part of the formula. This 2 and this 7 were actually originally positive. So if these numbers are negative, I bet I know what's going to happen when I place them into my formula. So if I do y minus -2 for y minus y1, again, that turns into a plus sign. Then it says equals 3 is the slope times x minus x1, and that is -6. Again, it happens again, minus -6. So I'm just going to change that to a plus sign as well. All right, you are doing these 3 on your own. I am going to move on. You can pause the video or come back at the end to do those on your own, but I'm going to move on to these. All right, so now we are graphing. Again, I'm going to do 2 of them with you, and then you're going to do 1 of them on your own just to see if you can do it. All right, so let's look at the first one. This is written in point slope form. Y minus y1 equals m times x minus x1. Now notice they don't have minuses, which is weird because minuses were part of the formula. When you see plus signs like this, it's probably because something like that happened where there were both negative numbers put into the formula to make a minus negative. When that happens, they have changed it, or anybody, we should change it to a plus. So I can tell that this is technically a -4 and a -2. Remember, this is the x1 value, this is the y1 value. So my coordinate goes -2, -4. Okay, remember we decided they were negative first of all. We also know that this is the x, which goes first in a coordinate, and then the y goes next in the coordinate. When you're plotting coordinates, the x value comes from this line, the y value comes from this line. So since I'm looking for -2 for my x value, that would be here. If I'm looking for -4 for my x value, that would be down here. So I'm going to put a point right there. Then I look at my slope, and I try to see what my slope is telling me. My slope is telling me -3. I know that if I have a whole number, I can put, or an integer, I can put it over 1 to help me know that I am going down 3 to the right 1, because that's my rise over my run. If I'm going down 3 and over 1, it actually lands me down here in these words, which is annoying, but I did this on purpose because I want you to know that if you're not able to go down here this way, go the opposite way. So go kind of backwards. Do the same pattern, just backwards. So if I really did draw a dot back here, I would still be drawing a perfectly straight line. Nothing changes. I just kind of extend the line a little bit. It helps me to know that I can go any way either way, as long as I'm going the right direction and the right numbers. Okay, so that's my line. All right, let's look at this one right here. We're graphing y minus y1 equals 1/2 times x plus 3. Interesting, because we have this plus. Remember that usually we're supposed to have minuses. We do have a minus right here, so that's good. All right, so I have an x1 and I have a y1. If I'm trying to find my coordinate, I know that this x1 is probably going to be -3, because the only way that this would have been +3 is if this said x minus -3, which that meant -3 was my x coordinate. Y coordinate is actually just plain 1, because remember that minus sign is part of the formula. So if I'm going to plot -3, 1, it would be over here, -3, 1. And then my slope tells me 1/2, which I go up 1 over 2, up 1 over 2. I'm making my pattern, and there is my line. All right, your turn on this one. Be careful with this -2 here as your slope. And remember, it is over 1, and these minus signs are part of the formula. Don't get them confused, and you should not be drawing any negative coordinates, because I can tell both of those numbers are positive in the coordinates. All right, let's look down here. Remember, you're doing this one on your own. I'm going to go ahead and keep going, though. This one right here, y plus 1 equals 1/5 times x minus 5. This is a point slope form, but we're going to try to convert it to y equals mx plus b. If you like working with y equals mx plus b more than point slope form, you can change it. This is how. Take the number outside the parentheses and distribute it, because y equals mx plus b definitely does not have any, it does not have any parentheses. So 1/5 times x is 1/5 x. 1/5 times -5 is actually -1. All right, the only thing that is keeping this from looking like y equals mx plus b is this plus 1 right here. So if I was really wanting to, I could move that to the other side to go be with its friend, that like term over here. And then I'm left with y equals 1/5x minus 2. And now it is in y equals mx plus b. They are the same line, just different versions, same line, just different ways of writing them, different types of equations. All right, number 2 on that part is on you too. So go ahead and try these example problems and let me know when you're finished.